Hello students, welcome to my YouTube channel. In this video, I am going to solve numerical number 7 to 13 of exercise 8A for current electricity from the textbook Concise Physics by Selena Publishers for ICSE grade 10. So we are going to use these formulas while solving numerical problems of exercise 8A. Numerical number 7. In an experiment of verification of Ohm's law, following observations are obtained. Draw VI graph based on the information given. Alright, so we are asked to find out VI graph. VI. Now when we have to draw VI graph, which quantity will come on y-axis and which quantity will come on x-axis? As the question says VI graph, meaning potential difference V must be on y-axis, and since V is measured in volt, along with the quantity, its unit also must be properly labeled. So y-axis is labeled as V and the unit is written in the bracket. X-axis, current is there on x-axis, and what is the unit? Ampere. Unit is ampere. Now if you see, the potential difference is increased from 0.5 to 2.5, and in equal interval the potential difference is increasing. 0.5, then if I add 0.5 into that, it becomes 1, and if I add 0.5 into 1, it becomes 1.5. Likewise, we keep on increasing potential difference by 0.5. Okay, so if you see the corresponding value of current, there is uniform rise in the current. So every time when we increase the potential difference by 0.5, the current increases by 0.2. Okay, so on y-axis we can take these readings or these values in equal interval: 0, then 0.5, 1.0, 1.5, 2.0 and 2.5, and the current interval on y-axis will be 0.2. So we start with 0, then 0.2, 0.4, 0.6, 0.8 and 1.0. Alright, now let us mark these points on the graph. When potential difference is 0.5, current is 0.2. So 0.5, 0.2, this is our first point. When potential difference is 1, current is 0.4, 1.5, 0.6, 2, 0.8, 2.5, 1. And now when we connect all these points, what we get is a straight line. Okay, so all this, the line which connects all these points is a straight line, right? And that is what we get the graph for Ohm's law, based on Ohm's law. So this line or this graph is a straight line passing through the origin. Now based on this graph we can answer the questions. Potential difference V when the current is 0.5 ampere. So current 0.5 ampere will be somewhere here, the middle point of 0.4 and 0.6. So from there we can draw a vertical line that intersects with the line with the graph, and then we can find out corresponding value on y-axis. So 0.5 is the midpoint of 0.4 and 0.6. Alright. So the corresponding value of voltage will also be midpoint of 1 and 1.5, which is 1.25 volt. So voltage is 1.25 volt. Next, current when the potential difference is 0.75 volt. So find out where 0.75 will be on y-axis. That's right, between 0.5 and 1, 0.75. So when I draw a horizontal line and find corresponding current, that is the midpoint of 0.2 and 0.4, which must be 0.3. So the answer for B is 0.3 ampere. And C, resistance. Now resistance formula is V upon I, and if you refer the graph, V upon I is nothing but the slope of the graph. Alright, slope. So take any 2 points to find out the slope. I am taking two extreme points. That is point A here and point B as is at the origin. And then we can find out what is the slope of the graph. Alright, so when voltage is 2.5, 2.5 minus the voltage at point B is 0 upon current for 2.5 volt is 1 ampere minus 0. So 2.5 ohm is a resistance. Right, so to find the resistance here, we need to find out the slope of the graph. Next question. Two wires of the same material and same length. Okay. Wire 1, wire 2. Now they are having same material, meaning their resistivities will be the same. So rho 1 is equal to rho 2. They are having same length as well. So L1 is equal to L2. Have radii 1 millimeter and 2 millimeter respectively. So radius of wire 1 is 1 millimeter. Radius of wire 2 is 2 millimeter. Compare their resistances. Now whenever such word comes compare, meaning we have to find out the ratio. Remember this. So whenever comparison or compare word comes in the numerical, you have to find the ratio. Alright, so here we are asked to find out the ratio of resistance of wire 1 and the resistance of wire 2. Now resistance is rho L upon A, but rho is constant, L is constant, only area is variable. So we will use this fact R is inversely proportional to area and area is pi r square. Right, area is pi r square. So we can say R is inversely proportional to 1 upon pi r square, or we can say R is inversely proportional to r square. So now we will use this particular fact to find out the ratio of R1 R2 or for doing the comparison of the resistances. So R1 upon R2 can be written as R2 square upon R1 square. R2 is 2 millimeter, 2 millimeter, so 2 millimeter square upon 1 millimeter square. Now since there is a ratio here, millimeter square gets cancelled, right? So I am not converting radius into meter, because even if you convert in meter, that is not going to affect your final result. So 2 square is 4 upon 1. So comparison of their resistance is 4 is to 1. R1 upon R2 is equal to 4 upon 1. And the comparison of their specific resistances. So rho 1 upon rho 2, and these two values are equal. So comparison is, ratio is 1 is to 1. Next question. A given wire of resistance 1 ohm is stretched to double its length. What will be its new resistance? Alright. So let me first draw a wire. This is a wire of a particular length. Let's say length is L. And cross section area is A. Resistance offered by this particular wire is 1 ohm. So we can write the equation R is equal to rho L upon A, and the value of R is 1, that is 1 ohm. Now the question says this wire is stretched to double its length. Okay, we stretch the wire. Now when we stretch the wire, to double its length, its area must decrease, right? Because if we stretch the wire, okay, if we stretch the wire, its length is going to increase. So if length increases, area must decrease so that volume remains constant. It is not possible that you stretch the wire, okay, so its length increases and area also increases, or area remains the same. No, that is not possible, right? So if we increase the length, area has to decrease. So if length becomes double, if new length becomes double than the original length, the new area A2 must be half of the original area. Then only we can say that the volume of this particular wire remains constant. Because if we are stretching, we are increasing the length, we are changing the length by stretching it, not by adding some, not by connecting another wire with it. Alright, so volume must remain constant. So for that, if length increases, area will decrease by the same factor. So now R2 is rho L2 upon A2. Rho L2 is 2L1 and A2 is A1 by 2. These 2 will go in numerator. So we can write it as 4 times rho L1 upon A1. Let me write initial length is L1, area is A1. So R1 is rho L1 upon A1, which is 1 ohm. Okay, so now I can say 4 times 1, 4 ohm. So new resistance becomes 4 ohm. After stretching the wire, after increasing its length by 2 times, the resistance becomes 4 times, 4 ohm. Because not only the length, area also gets affected here. Next, a wire of resistance 3 ohm and length 10 centimeter is stretched to length 30 centimeter. Okay, so initial length is 10 centimeter. Now, okay, so when length is 10 centimeter, L1, area is A1. So that resistance is rho L1 upon A1 and that is given 3 ohm. Alright, now the question is the resistance wire of length 10 centimeter is stretched to the length 30 centimeter. Assuming that it has uniform cross section, what will be the new resistance? Now this is very important to understand what is the meaning of this phrase, it has uniform cross section. Now see, when I stretch this wire, okay, there are two possibilities. Possibility number one is that I stretch the wire like this. Okay, I increase the length of the wire by stretching, but as you can see here, the area is not uniform throughout its length. Area changes. Okay, area changes from as we go from left side to the right side, area changes. So this is one way by which we can stretch the wire. And the second way is you stretch the wire but make sure that the area remains same throughout the length. Okay, area is uniform throughout the length. This is what it means by this particular phrase, that the area it has uniform cross section area. The statement is not, you see here, understand that here the statement is not like this, that the area remains constant. The statement or the phrase is it has uniform cross section. Uniform word is not used. Okay, the word is not constant, the word is uniform. So when I stretch the wire like this, I can say that the area throughout the wire is uniform. So area definitely decreases when we increase the length, but its area remains uniform throughout the length. So new length is 30 centimeter. So we can say L2 is 3 times L1 and hence new area must be 1/3 of the original area. So now R2 is equal to rho L2 upon A2. New length is 3 times L1 and new area is 1/3 of the original area. So this becomes 9 times rho L1 upon A1. 9 times 3, 27 ohm. So when you stretch the wire by 3 times, new resistance becomes 27 ohm. A wire of resistance 9 ohm having length 30 centimeter is tripled on itself. What is its new resistance? So what do we mean when we say tripled on itself? This is the wire of length 30 centimeter. Now tripled on itself means we fold the wire, okay, we fold the wire like this. So after folding the wire, this is what the situation is. Area is, let's say, initial area is A1. Now this new area, as you can see in the diagram, is 3 times A1. And length, the new length after bending this wire on itself, okay, the new length becomes only 10 centimeter, 10 centimeter. So we can conclude that this new length L2 is L1 by 3. So new area has to be 3 times A1. Then only we can say that volume will remain the same. Okay. So for the original length 30 centimeter and area A1, resistance is rho L1 upon A1, that is 9 ohm. New resistance R2 is rho L2 upon A2, that is rho L2 is L1 by 3, and area is 3 times A1. This is 1 by 9 times rho L1 upon A1, and rho L1 upon A1 is 9 ohm. So 1 by 9 into 9 is equal to 1 ohm. So R2, or the new resistance, becomes 1 ohm. So after folding the wire 3 times on itself, new resistance becomes 1 ohm. Next question. What length of copper wire of specific resistance 1.7 into 10 to the power minus 8 ohm? So resistivity is 1.7 into 10 raised to minus 8 ohm meter, and the radius 1 millimeter. Resistance is 1 ohm. So what must be the length? Alright, so now this numerical is based on the formula R is equal to rho L upon A. We want to find out length. So let us make L as a subject first. L is equal to R times area upon resistivity. Area is pi r square. So R pi r square upon resistivity. Now let us substitute the values. R 1 ohm, pi 3.14, radius 1 millimeter. So that 1 millimeter must be converted into meter. So 1 millimeter is 10 raised to minus 3 meter, square of that, upon resistivity is 1.7 into 10 raised to minus 8. So when you simplify this, you will get the answer 184.7 meter. Alright, so use some your mathematical skill and find out that this answer is 184.7 meter. Alright, last numerical of this exercise. The filament of the bulb takes a current of 100 milliampere when a potential difference across it is 0.2 volt. So current is 100 milliampere, potential difference 1 volt. The current, when the potential difference, here it is 0.2 volt. Now it says when the potential difference across it becomes 1 volt. So let me write this as V1 I1. When new potential difference is 1 volt, the new current is 400 milliampere. Calculate the resistance of filament in each case and account for the difference. Alright. So let us find out R1 here. Formula is V1 upon I1. V1 is 0.2 upon 100 milliampere. 100 milliampere. So 0.2 becomes 2 upon 10 into 100 milli is 10 to the power minus 3 volt upon ampere. Okay, and volt upon ampere is also known as what? Ohm. So this 10 into 100 is 1000 and 10 to the power minus 3 gets cancelled. So answer is 2 ohm. R1 is 2 ohm. Similarly, we can figure out what is R2. V2 upon I2. V2 is 1. I2 is 400 milliampere, that is 400 into 10 raised to minus 3, that is 1 upon 4 into 10 raised to 2 into 10 raised to minus 3, that is 1 upon 4 into 10 raised to minus 1, minus 1 will go up, so it becomes 10 upon 4, 2.5 ohm. Okay, so R1 is 2 ohm and R2 is 2.5 ohm. Now why resistance increased? Because as you see here, the current increased, and we know that as the current flowing through the filament increases, okay, as the current flowing through the filament increases, its temperature will increase because some amount of energy will be lost in terms of heat. Okay, so now the temperature of the filament increases, that increases the resistance. Thank you.